In today's lesson, we're looking at an idea called conditional probability. So as the name suggests, conditional means that there's some sort of condition placed on it before we work out our probability. So our learning intention is to understand and interpret notations for conditional probability and also to actually calculate these probabilities. So by the end of this lesson, you should be able to interpret the notation into words. So again, it's going to be a little bit of set notation, and also to calculate the conditional probabilities based on information provided. So again, like with the previous concept, we will have formulas that we can use to solve these questions, but sometimes we can also do them just by inspection, so a much more informal method as well. So conditional probability is the probability an event occurs given that another one has already occurred. So it's sort of like linking the two to each other. So in our example, in the following Venn diagram, we have the number of students who own a dog or a cat. So we've got students who own a dog in here, ones who own a cat in here, and then we've got these 5 people on the outside who own neither a dog nor a cat. So a student is chosen at random. Find the probability that, first one, the student owns a cat given that they also own a dog. Okay, so this is what it means by conditional. So if we already know that this student owns a dog, what is the probability that they own a cat? So what that means is when you're looking at this diagram, we're actually going to hone in onto just this circle right here. So given that they own a dog, what is the probability that they also own a cat? So we have 3 cats out of the total of 9 people. So the probability student owns cat given they own a dog is going to be those 3 people in the overlap out of a total of 9. Well, that's 1 out of 3. So what we're doing is when we're looking at conditional, we're honing in onto a certain section of our whole diagram. The next one, all I've done is flipped it around. So the student owns a dog given that they also own a cat. So this time we're going to focus on the cat people. What is the probability of those cat people? They also own a dog. So the probability, student owns dog given they own a cat. So out of all of those cat people, which is 10, we have 3 people who own a dog. So then the probability is 3 out of 10. So you can see you have to be very careful with the terminology, making sure that you have the right numbers in your calculation. And the last one, what is the probability the student owns a cat given they own exactly 1 pet? So when we're looking at this diagram, then we need to make sure we pick and choose what numbers we're going to be using. So if they own exactly 1 pet, we're looking at the dogs only or the cats only, and we're looking at, of those people, what is the probability that we have a cat? So you can see we've got 13 people altogether, and 7 of them own a cat. So the probability student owns cat given they have 1 pet is the 7 cat owners out of the total of 13. So the probabilities do change a fair bit. What you want to do is, if you are given a Venn diagram, make sure you're reading that carefully. Now, you can see when we wrote these out, we had to write out quite a lot of words in order to describe what we're doing. There's actually a much simpler method that mathematicians use, and it involves the set notation. When we're using set notation, it also allows us to write these as formulas rather than just try to draw out a Venn diagram and interpret it from there. So there are formulas that we can use to work these out quite quickly. So when we write out conditional probability, so again, we're talking about two sets, okay? So two groups of elements that are going to work together. How we write it is we've got probability A, and then we've got this line, kind of like your absolute value symbol, okay? So it's like a nice big line there separating A and the B. And basically how you read that is you're finding the probability A occurs given B has already occurred, okay? So that's how you would go about interpreting it. When we go to work this out as a formula, basically the probability that A occurs given B is the number of ways that both of them are occurring over the number of ways that B only occurs. So if we go back up to these questions, that was pretty much what we saw. I lost a 9. That's pretty much what we saw here. So when we did the first one, student owns a cat given that they own a dog, what we did was we were looking at this circle here, and we took the number of people who own both over the number of people who own a dog. Okay, so the overlap is really your numerator value. And so you can see here A intersection B. So the number, so N for number, the number of items in the overlap over the number of items in B. Okay, because remember we said given B, which means that B's already occurred, so we're focused on just the people who were in the B circle of your Venn diagram. Now another way we could write this is rather than looking at the number of items, we can also write this as probability. So the probability of getting the overlap over the probability of having B occur. Okay, so that's another way that we can write out this equation. All right, so let's have a look at this question. In a certain population, 35% of people have blue eyes, 15 have blonde hair, and we've got 10% have blue eyes and blonde hair. Person is chosen at random. What is the probability they have? And we've got blonde hair given that they have blue eyes, and then we're going to switch it up again. So how we can write this out is the probability, we want the probability that they're going to be blonde given that they have blue eyes. Oh, blue. So what that means is if we were to follow this formula here, because these are percentages, we could treat them as probabilities. So we're looking at the probability of getting both of them over the probability of B happening. So that would be the probability of blonde and blue. If you want, you can use the intersection symbol there over the probability that they have blue eyes. So the probability that they have blonde hair and blue eyes is 10%. The probability that they have blue eyes is 35%. And then simply we'll just simplify this. So 10% divided by 35%, that's 2 out of 7. If we go the opposite way, so we want the probability of blue eyes given that they have blonde hair, that's going to be the probability blonde and blue over the probability that the person has blonde hair. So like from before, we had 10% for blonde and blue eyes. We have 15% who have blonde hair. So then when we simplify that, that should come out to be 2/3. Sometimes it's much easier to use the formula, But sometimes it is quite intuitive as well, like what we saw in the Venn diagram. So you're focusing on a specific section of your Venn diagram rather than trying to use all of the numbers at the same time. So here's some questions for you to have a go at. Let me know if you've got any problems.